A next-generation particle collider is likely to cost over $30 billion. Yet there has been little progress fixing problems affecting our everyday lives. The work has failed to make the breakthroughs needed for radiation-free nuclear power or anti-gravity propulsion. We must cancel the future collider because high-energy collisions are distracting us from making any useful discoveries. In the Higgs theory, it was assumed that photons or light has no mass. Yet we accept that light from the sun carries energy, and from E=mc², it must also have mass. It turns out the problem is a misunderstanding caused by a figure of speech. The following statement is from a distinguished European government physics lab. Photons are traditionally said to be massless. This is a figure of speech that physicists use to describe something about how a photon's particle-like properties are described by the language of special relativity. If you find this confusing, it is a smokescreen to make us not realize the importance of the photon in particle mass. Instead, we are forced to accept overcomplicated, kludged together theories involving high-energy force carriers. Maxwell's equations have shown us for over a century that the photon's speed is fixed at 3 × 10⁸ meters per second for a vacuum. This was the massive mistake, forgetting that photons cannot exist while stationary but other particles can. The theory should have compared moving photons to other particles having rest mass. Maxwell's equations explain well how radio waves radiate like ripples in a pond from the transmitting antenna. They are no good to explain how at much shorter wavelengths the radiation forms quantized packets, as in Max Planck's famous equation E=h×f. The electric wave packet distorts space-time following a simple mechanism. The distance swept out by the electric charge wave function is proportional to its frequency. Due to the electric charge dimension being contained inside normal space-time, this causes the length of the wave propagation axis to stretch. This causes a lensing effect that stops the packet of radiation spreading out. The length at the middle of the wave packet exceeds the length at the edges. This difference forces radiation attempting to leak out inward and back to the center. The photon can change into a stationary matter particle very easily. Physicists call this pair production. In particles such as the electron, and also the quarks inside the proton and neutron, there is actually a standing wave photon. The standing wave particle can exist while stationary or moving below the speed of light. The mechanism of the standing wave is very simple. All the oscillations of the electric wave function add up to make a single wave which orbits round a central mass packet. The spin-half property is due to there being 2 different shaped orbits before the cycle repeats. The 2 orbits are elliptic and of different radius. In the outer orbit, the electric field is free to project in all directions to create the particle's point charge. The inner orbit has the wrong sign for the electric charge, but is so close to the center of the mass packet that it is completely shielded from outside. Higgs theory completely fails to explain inertia. The Higgs mechanism gives mass to matter, but does not go on to explain why mass resists acceleration. It turns out that Einstein's general theory already provides that fix. From his equivalence principle, we cannot tell the difference between the weight we feel due to gravity or acceleration from an external force. Inertia works the same way as gravity. The general theory shows us that gravity creates an acceleration from the forward motion of time. If time is on the x-axis and the spatial dimension is on the y-axis, then this curvature creates a force from the pushing forward of the arrow of time. Applying the standing wave photon model, inside the mass being accelerated will be its internal much smaller gravitational field. Its shape will distort when any external force is applied. In the case of normal atoms, the force will begin with the electric charge repulsion between electrons on neighbouring atoms. This in turn will be coupled to the forces on the electric charges associated with the mass-giving particles, the quarks making up the nucleus. The force on the quark's electric field will pass on to its mass packet. With inertia, the acceleration is in the same direction as the applied force, and this is why we feel heavy in our car seats when we speed off from the traffic lights. When an external force is applied, the region of space-time accounting for the mass warps in such a manner that its curved geodesic becomes unbalanced and pushes against the applied force. Space-time is now being curved in such a manner that the accelerative force, typically from our car engine, pushes against the arrow of time. If the acceleration is stopped, for example, we suddenly notice a police car, we will continue to move with linear position versus time. To decelerate, for example, we've just been blue lighted by the police car, we must uncurve space-time by applying a force from the opposite direction, normally by applying the car's brakes, but a crash barrier or tree would be equally effective. The time integral of the asymmetry of the mass's gravity well then sets its momentum. We now need to explain what was discovered in 2012 in the Large Hadron Collider and why it made world news headlines. Very little was actually discovered, and the media hype was a public relations exercise. In experiment, counter-rotating beams of protons and antiprotons were accelerated to over 99.99% the speed of light. The beams were made to collide in the heart of detectors the size of buildings, housed in vast underground caverns. In a vast majority of the collisions, the protons do not collide head-on, and other particles such as pions emerge from the debris. There is nothing new here. Searching for the Higgs amongst all the collisions was a real challenge and needed global-sized computing power. The Higgs has an annoyingly short lifetime of a trillionth of a billionth of a second. It cannot be directly detected because it has no electric charge. We therefore have to look for decay products that are hard to distinguish from the debris of other particles. After spending $13 billion, the best evidence is this graph showing a small hump on an irreducible background. When the collision energy is set around 125 giga-electron volts, a Higgs boson is produced in 1 in 10 billion collisions. The two protons have to collide exactly head-on, and since the proton nucleus is 9 orders of magnitude smaller than the beam radius, the chance is nearly zero. The Higgs is created out of the enormous relativistic mass increase of the colliding protons. They have gained over 100 times their rest mass in the accelerator. Their momentum cancels exactly in the head-on collision, and the mass forms a single stationary mass packet. There is no electric charge because of the intense distortion of space-time. Since the mass packet size is many orders of magnitude too small to be self-supporting, it decays almost instantaneously into other common particles. Higgs explains symmetry breaking in the Mexican hat graph. It distinguishes between normal flat space-time and the insides of a black hole. We need flat space-time to create electromagnetism and mass in everyday atoms. This is the middle bit of the Mexican hat, and the strange mathematical hieroglyphics showing something not equal to zero. The Higgs boson cannot exist here, hence the difficulties of the LHC experiment. Higgs theory is criticized from many angles. It is a black box theory and makes no attempt to explain its internal workings using simple language. It does not tie in with earlier work from Einstein. To give the hat graph some simple meaning, the Higgs field is a measure of the curvature of space-time, and the Higgs potential is the associated mass increase. In other words, it is exactly the same as Einstein's gravity equation. The vacuum expectation value has a positive value in our present universe because electromagnetic fields exist and they support mass in atoms. A popular criticism is the hierarchy problem. The measured mass of the Higgs boson is too low to tie in with theories about something called the Planck mass. The final section reviews other similar theories, which are called extra-dimensional Higgs models. An internet search shows that the Randall-Sundrum model is the best fitting theory. In the explanation text there is a lot of jargon. Brain is not a misspelling, it means a system of dimensions. Anti-de Sitter has nothing to do with dog obedience classes. It is an elaborate way of saying that the universe is curved like an inflating balloon. If we travel in one direction in a straight line, we end up where we started. The theory description in the bottom paragraph is slightly wrong. The transition between the gravity brane and the TeV brane is highly non-linear due to electromagnetism switching off when gravity time dilation effects reach a point where light cannot escape. For a more detailed explanation, please read the accompanying .pdf article. The link is given in the explanation text below the video.